Greetings, my name is Brian, and I'm here to talk about optimization of turbine for overtopping wave energy conversion device through computational fluid dynamics simulation. In the recent studies, energy demand in Malaysia is expected to increase uniformly, as shown in the slide. However, petroleum, coal, and natural gas is the major energy sources in Malaysia, as these types of energy supplies will deplete over time. Not only these types of energy supplies will damage the environment around our beautiful natures in our country, but will also affect our country's finance in the future. And therefore, as an engineer, a solution is proposed to tackle this very own problem, which is by slowly but surely improving the development of renewable energy in Malaysia. But what renewable energy, you may ask? Well, did you know out of 195 countries in the world, Malaysia is placed in 29th with the largest coastal area in the world. This means that the accessibility of ocean energy in Malaysia is in good standing, and hence ocean energy is chosen as the best candidate. However, the potential of ocean energy is mostly based on the sea wave characteristics available. Therefore, the wave characteristics in Malaysia Sea is researched. Based on Malaysia's meteorological services, the wave characteristics in Malaysia is as shown in slide. The average annual wave energy is below 5 kilowatt per meter, while the average annual significant wave height ranges from 1.1 meter to 1.3 meter. Based on this information, a suitable available turbine head is calculated to be around 0.4 meter to 0.6 meter. Now, there are several types of devices that allows us to extract energy from the ocean, mainly the oscillating water column devices, the oscillating body power converters on the right, and lastly, the overtopping wave energy converter device. You may ask, why did I choose overtopping wave energy converter device? Well, based on the research done by Aderinto and Lee in 2019, involving more than 40 types of ocean wave energy converters, regardless of the site resource, the result shows that the performance of overtopping wave energy converters stays constant. And since Malaysia's sea wave characteristics are considered as low end, overtopping wave energy converter is chosen. Now, the power takeoff system, which consists of the turbine itself, plays an important role in overtopping wave energy conversion device as it affects the overall performance of the device. The average of efficiency of a hydro turbine is 85%. Now, with all these available informations, of course, the turbine is main focus as it affects the performance majorly, and hence the research title as proposed. Now, here's the research questions and the research objectives. For research questions, what kind of turbine designs optimizations that affects the performance of turbine? What is the performance of optimized turbine? And on the other hand, for research objectives, to characterize the turbine performance, to design and simulate the turbine, as well as to evaluate the performance of turbine design optimized. So for the critical literature reviews, the Malaysia's wave characteristics are researched and obtained as shown in slides. And with the wave characteristic obtained, the Kaplan turbine is chosen as shown on the right side of the slide. And after intense literature reviews, most research studies on the turbine outer blade diameter, the number of blade, as well as the geometry of turbine casing. However, not much research studies on all these three optimizations at once, let alone in Malaysia's sea wave characteristics. And therefore, these three optimizations are chosen. So methodology of this research is proposed as shown in the slide. There are three phases in methodology. Each methodology phase dedicates to tackle each and every objectives proposed in this research. Phase 1 is to characterize the turbine performance. Firstly, we have the blade profile of the turbine. Based on few literature reviews, Kaplan turbine mostly utilize NACA 4000 series airfoils, and NACA 4412 airfoils are the most common, and therefore NACA 4412 airfoils are used. The blade profile of the turbine affects the lift and drag mechanism of the turbine, and hence affect the turbine performance. Secondly, the boundary conditions are important as it indicates the performance numerically and provide validation to results. Without any of these boundary conditions, the calculation of performance cannot be validated, and therefore boundary conditions are important. Here are the list of boundary conditions obtained from the MATLAB software. On the right side, the turbine design optimizations are listed. Now for phase 2 dedicates to design and simulate the turbine. With the aid of MATLAB software and SolidWorks, the precision and accuracy of drawing the complicated curvature of turbine blade is obtained. As shown in the slide, the turbine design and PTO system is drawn all by using the help of Microsoft Excel, MATLAB, and SolidWorks. The designed turbines are then simulated through ANSYS Computational Fluid Dynamics software. During the process of simulation, the validation of results and processes are checked, such as the meshing size, the setups, as well as the model used for solution sections. Throughout the simulation process, several results are validated based on visual aspects as well. Visual aspects such as pressure control on turbine, streamline of water velocity, and plane contour for water velocity. Now for phase 3 of methodology is dedicated to evaluate the turbine optimized performance. Take note that the results shown in the slide is based on the optimizations of turbine blade diameter and number of turbine blade only. The power output is calculated based on torque acting on the turbine multiplies with the angular velocity of turbine. Yes, this means that the results are based on mechanical performance efficiency. The results shows that Model 2 has the highest efficiency with 62.87%. This is considered as very low and not effective enough. And this may be due to the absence of whirl velocity in the turbine. As you can see in the slide, the water from the inlet enters in straight without any whirl effect. And therefore, the last optimizations are added into the turbine design of Model 2. This time, the inlet has a spiral casing which creates whirl velocity effects on the turbine. The power efficiency of the turbine shows a drastic change with 94.44% efficiency. You may think to yourself, 94.44% is very high. Well, in the recent studies, the highest efficiency of hydro turbine is obtained to have 96%, and therefore this research still needs more work on increasing the performance of turbine. In conclusion, the result shows that the diameter of runner blade shows a higher effect towards the turbine performance compared to number of turbine blade. On the other hand, the type of inlet casing shows a drastic increase in turbine performance. The objective of this research are completed as well, and ocean wave energy in Malaysia is proven to be reliable, and therefore the research is considered as a success. Thank you.